Hi Math 30s. I wanted to make a quick video on how you would write the domain and range of rational functions. So what I want you to do is take out a sheet of paper, a blank sheet of paper where you could write down these 4 graphs, or flip to I believe it's at the beginning or end of your notebook, you should have some blank pages. And just take a minute and quickly get these 2 graphs illustrated, and then just a quick sketch of these 2 graphs. Okay. I want to talk about this first graph. This is a graph you would have seen in Math 10C or Math 20-1. It's a linear graph. The graph will go forever to the right and it'll go forever to the left. So if I said in Math 10C or 20-1, what's the domain of this graph? You would say, okay, well for the x values, if the x keeps going, it would go to infinity. If the y keeps going, it would go to negative infinity. So the domain of this graph, if we were writing this in set builder notation, it would be x is such that x belongs to the set of real numbers. So that would be the domain in set builder notation of a linear graph. If we were writing this domain in interval notation, you would say, sorry, it has to be a rounded bracket. You would say the domain goes from negative infinity to positive infinity. And that would be the domain in interval notation. The range would be the exact same thing, except for range, we're discussing y values. So in set builder notation, y is such that y belongs to the set of real numbers. And in interval notation, we would say our graph goes from negative infinity to infinity. Remember that when you're dealing with interval notation and we have infinity, you will always use rounded brackets, never squared brackets. So this would have been the domain and range if it was a linear function. What I'm going to do though is I'm going to make this a rational function, and I'm going to put a point of discontinuity. So I'm going to put the point of discontinuity right there. And now what I'm going to do is show you how we would write the domain and range if there's a point of discontinuity or if there's a hole in your graph. So we know that this point is -5, -10. So what I always tell students to do, get your point of discontinuity on the graph, write your x value, and write your y value. Now, for domain and range, whenever we have a rational function, we cannot use interval notation. It must be set builder notation. So start your bracket and write x is such that. Now, normally we say x is a set of real numbers, right? X could go from to negative infinity to positive infinity. So x is a set of real numbers, but x cannot be -5. So what you would do is you would say x is such that x could not be equal to -5. So put what the restriction on x is, and then you would say comma, other than that, x belongs to the set of real numbers. So what this is telling me is that your x values are the set of real numbers. It just cannot be this one value, which is -5. If I was to do the range, I would say, okay, this has to be done as soon as I have a point of discontinuity or a vertical asymptote, a horizontal asymptote, I have to do set builder. So y is such that y is normally the set of real numbers, except what can y not be? Y cannot be -10. There's a hole at -10. So state the restriction on y. It cannot be -10, comma, y belongs to the set of real numbers. This would be how you would write your domain and range for this first graph. If I was to go to the second graph, there's my x value and my y value. There's a hole or a point of discontinuity at x is 3 and y is 2. So the domain of this graph in set builder notation is saying x is such that, tell me what x cannot be. It cannot be 3, but other than that, x belongs to the set of real numbers. X is any number except for 3. For the range of this graph, what could y not be, right? There's a hole when y is -2. So you would say, okay, the range of this graph is y is such that y cannot be equal to -2, comma, y belongs to the set of real numbers. So this is how you would do the domain and range if you have a point of discontinuity or a hole. In this graph here, I don't have any points of discontinuity, but I do have a vertical asymptote. So this is the vertical asymptote of my graph at x is equal to 3, so that's the equation of my vertical asymptote. But what that means is this graph here is going to go forever until it touches infinity. This graph is going to go forever to negative infinity, until it approaches negative infinity. So my domain for this graph here is x is a set of real numbers, but what could x never be? X could not be equal to 3. Right? There's a non-permissible value, a vertical asymptote at x is equal to 3. That means that my graph at x could never be 3. So how I would say my domain of this graph is, I would say x is such that x cannot be equal to 3, comma, other than that, I'm basically saying x belongs to the set of real numbers. Range. There's no point of discontinuity for y. If I said, what's your biggest y value? You would say, well, that side is approaching infinity. This side is approaching negative infinity. There's no horizontal asymptotes, so the range of this graph would be y belongs to the set of real numbers. Y is such that y belongs to the set of real numbers. Okay, this last graph here, x is equal to -1. That is a vertical asymptote at x is equal to -1. That's the equation of this vertical asymptote. Therefore, what that means is my domain, x cannot be equal to -1. So if I was to do the domain of this graph, I would say the restriction on my graph of x, so x is such that, state your restriction, it cannot be -1. Other than that, it belongs to the set of real numbers. The range of this graph. I haven't yet taught you what horizontal asymptotes are. That's in the next lesson. But this line here is a horizontal line that my graph approaches, but it never touches. So this is what we would call a horizontal asymptote. This graph has a horizontal asymptote at y is equal to 2. Right? So my y values on this graph approach 2, but they will never touch or cross 2. So therefore, the range of this graph, y cannot be equal to 2. That's the restriction. So if I was to say the range of this graph, it would be y is such that y cannot be equal to 2. Other than that, y belongs to the set of real numbers. If you don't understand this one, that's okay for now because, like I said, we haven't done horizontal asymptote yet. But when you see a horizontal asymptote, whatever the horizontal asymptote, y cannot be equal to that number, and that would be the restriction on the range.